Yes, good morning to you all. I hope my audio and video is working fine. Yeah, as you know, today today is the you see today is the ninth session of our discussion under this climatology. Today will be the last session. From tomorrow we will start with oceanography. Okay, we have tried to cover almost all the important points. Only one section will be left behind, that is cyclones, temperate as well as the tropical cyclones, which we will take up during our discussion under Indian geography. Okay, because tropical cyclone usually happens in the tropical region, has a very important significance in the Indian climatic condition, weather phenomena, agriculture, disaster management. There are many other important aspects. And also the dynamic nature of the tropical cyclonic circulation in the Bay of Bengal and Arabian Sea coast. How it is changing in the recent past because of the global warming and climate change which is taking place, which I will take up in our discussion of Indian geography part. Okay. Anyways, let us go ahead with our discussion. But before we go into it, I have some important information to share from Unacademy platform. That is, you see here, one major price hike, price rise or hiking in the price of the course was supposed to be today, that is 16th of December. But because of popular demand, it has been extended to 23rd of December. Clear? Therefore, based on that, price hike will happen, for plus compo subscription as well as for plus GS subscription like this. So before this particular hike in the price, you kindly subscribe if you haven't done so. Another very important point is you will get a 3 months extension on every 1 year and above plus GS and plus combo subscription. Okay, so you kindly do so. You are getting 3 months, approximately 90 days. It's a very it's a very long period of time. Okay, kindly do so. Now another course, comprehensive batch courses on GS for UPSC CSE, especially for 2022 and 2023, is getting started on 22nd of December. Mission 2022, Lakshya 2022, Mission 2023, Lakshya 2023. Okay, so you can enroll in any of this course. Okay, your prelims is in the month of June, so only hardly 6 months left. Therefore, you kindly enroll for the course which are studying. Nothing like preparation for your prelims via MCQ, that is multiple choice question. Now it helps in two ways. One is it will help you in practice time management, and the other is you will revise the points that you have discussed, the points that you have or the topics that you have studied. Okay, revision. Best way of revising a topic that you have studied is through this MCQ. Taking this into consideration, in Unacademy you have a free test series in order to help you in your preparation, especially for your prelims, which is hardly 6 months to go. One is Mrunal's Monday. Every Monday at 8 p.m. It is available both in English as well as in Hindi. 20 MCQ in 20 minutes. T20 current series, that is 15 MCQ 15 minutes. Monday to Friday 7 p.m. both in English as well as in Hindi. Abhiyan, which is a daily static portion, it is also 15 MCQ 15 minutes. It is available both in English as well as in Hindi, Monday to Friday 10 a.m. You can use my enroll code, that is SUNEP10. Clear? Again, you have this UPSC Mega Compact, the ultimate support for your UPSC CSE preparation. 56 questions in 60 minutes. You will get scholarship as well as amazing prices. For enrolling here, you can enroll. This is every Sunday 11 a.m. The upcoming Sunday, that is 19th of December, you can use my code SUNAP10. Clear? Let us quickly go ahead with our discussion today. Yesterday we have already completed different types of cloud. Okay, and also related to that, we have seen what are the different types of precipitation, different forms of precipitation. Okay, today let us go and see zonal distribution of rainfall. Now you see here, the rainfall that you will observe on the earth's surface, that is, if you go from equatorial region to polar region, you observe certain kind of patterns. Patterns in a sense, say for example, this is your globe. This is equator. Local variation will be there. We are not ruling out the local variation which may be present. But all in all, if we consider the general characteristics, you will find that the rainfall pattern, precipitation that is happening on the earth's surface changes as per the zone, means as per the different latitude. Because you know, rainfall is nothing but a function of temperature and moisture content. Now we know that the temperature, the actual temperature variation is also a little bit different. Local variation will be there, but it is zonal in characteristics. Therefore, following this, if you go and observe the rainfall pattern, they are zonal in characteristics, means different zones as per the latitude. Now the maximum amount of precipitation comes near the equatorial region. Okay, equatorial region. And the type of precipitation, I am not explaining it here again. Why? Because we have already seen yesterday what are the different types of precipitation. Frontal precipitation, convectional, orographic, we have seen all of those different types of precipitation. Maximum type of precipitation which will happen in the equatorial region is because mainly of the convectional activity. Okay, keep this in mind. Therefore, in the equatorial region, usually in the afternoon or late afternoon, there will be intense rainfall because of heating up right from the morning. Now, the second zone is the trade wind rainfall zone, that is 10 to 20 degree north and south latitude on the eastern side. Why? Because you see here, this is globe, equator, okay, subtropical high, trade wind blows like this. Therefore, the eastern side, so whenever a trade wind is blowing like this, while it is blowing over the water body, it is carrying lot of moisture. When it hits the land area on the eastern side of the continent, then huge amount of precipitation will come on the eastern side. Clear? On the western side, it will be away from the land area, so no precipitation. But on the eastern side, in this 10 to 20 degree north and south latitude, you will have a precipitation which will be because of the trade wind. In the subtropical region, you will have a minimum rainfall, that is 20 to 30 degree north and south latitude. Why you will have a minimum rainfall in this subtropical zone? Why? Because subtropical high, which means the air is coming down from above, going out in all the possible direction on the ground surface, which means there won't be any kind of cloud formation. When there is no cloud formation, where is the question of precipitation? Okay, therefore, most of the hot desert you will find in this particular zone, subtropical zone of minimum rainfall. Mediterranean region, somewhere around 30 to 40 degree north and south latitude, you will find this particular winter rain. That is, you see here, we already seen the shifting of the pressure belt. During the northern hemisphere summer season, the pressure belt shifts to the south. Similarly, the subtropical high pressure belt also will shift towards the south, like this. Now, from this subtropical high pressure, one wind is blowing like this, that is trade wind towards the equatorial trough. The other one is blowing like this in the form of westerly. Now say for example, if I have one region here in this location, when the shifting of pressure belt is not there towards the south, then this location is not coming under the rainfall. Why? Because westerly is blowing like this. But when this subtropical high pressure belt shifts towards the south, this will come under the influence of this westerly. And this westerly, after traveling over the water body, be it Atlantic or Pacific Ocean, it carries sufficient amount of moisture. Therefore, in the winter season, this Mediterranean type of a region, that is around 30 to 40 degree north and south latitude, you will have this winter rainfall. That is one of the peculiarity of this Mediterranean type of weather and climatic condition. Say for example, in monsoon type, like the weather condition that we have in India, we have rain in the summer, dry in the winter. In Mediterranean region, it is just the opposite. It is rain in the winter, dry in the summer. Clear? Mid-latitude zone of high rainfall is because of the westerlies. Again, at 40 to 50 degree latitude, you will have on the western side there will be more rain. Why? Because see, trade wind affects the eastern side, because the direction of trade wind is like this. Direction of the westerly is like this. Therefore, the western side of the continent will be having more rainfall. Now, if you compare this mid-latitudinal zone, north and south, the southern hemisphere will have more rainfall as compared to the northern hemisphere. In this particular mid-latitudinal zone with the influence of westerly. Why? If you look at the map of the world, you will find there is less amount of land mass on the southern hemisphere. Therefore, the westerly which blows, it is blowing over the water body for a larger period of time. At the same time, because of that, it is more intense. Therefore, when it hits the land area, it gives lots of precipitation. Therefore, in this mid-latitudinal zone, because of the westerlies, if you compare the north and south hemisphere, in the southern hemisphere, it will be more rainfall. Polar region, on the other hand, will experience a very, very low rainfall. Clear? That is a basic zonal distribution of rainfall on the Earth's surface. It is also represented by a graph in this manner. This is equator, 0 degree latitude. This is southern hemisphere. This is northern hemisphere. You kindly observe the diagram which is in front of you. See, right at the equatorial region, because of the cloud formation, the sun insolation is not much. Therefore, the intense heating is a little bit towards the north. Therefore, the highest amount of precipitation is not happening exactly over the equator. It is a little bit tilted towards the northern hemisphere. That is one observation. The second observation is, you see here, in this particular middle latitude, as we have already discussed, maximum rainfall, same latitude, around 40 to 50 you can say, but in this particular middle latitude, maximum rainfall happens in the southern hemisphere as compared to the northern hemisphere. The reason we have already discussed. Least amount of rainfall will happen in the polar regions like this. Clear? This is the zonal distribution of precipitation. Clear? Now let us quickly go and see one important topic, that is air mass. You see here, what is air mass? Okay, what is air mass? In a very simple way, I can tell you, any air mass which is having a homogeneous characteristics. Now, any air having a homogeneous characteristics is an air mass. Now, when you are considering the air as a whole, what should be the characteristics? Temperature is one parameter, humidity another parameter. Okay, therefore, if I have a surface like this, if I have an air over this like this, having a homogeneous characteristics, which means the temperature, the moisture content, okay, density, if they are homogeneous, which means you go to one place of this air mass, you check its characteristics, you go to the other place, you check the characteristics, you go to other place, you check the characteristics. If they are homogeneous, which means temperature, moisture content, they are similar, then such kind of an air which is over the surface of the earth is considered as an air mass. Clear? Now, this particular air mass has got many climate, is relevant for many climatic and weather phenomena. Okay, but you see here how this particular air mass will form. Let me give you one example. Remember the basic definition about this air mass. I have just mentioned to you, air mass means homogeneous air above a surface. Now, this air mass, these particular characteristics of an air mass is given from which side? The temperature, moisture content of this air mass is determined by what? It is determined by the ground surface. If the ground surface is warm, then the air mass over here, the air temperature over here will be warm. If this underlying surface is cold, then this air above this will be cold. Right? Now, I will give you another scenario. Kindly follow the pointer. Kindly follow the pointer, okay? Very important. This is a land area. Okay, this is a land area. This is a water body. What is the characteristics here? What is the characteristics here of temperature? Will this temperature will be same or different? Janiel Williamson, good afternoon and welcome to the session. Will this land temperature and water temperature, is it similar or different? Another point. The moisture content over the land and over the water, is it same or different? It will be different. Therefore, here, do you think a air mass will develop over this region? Over this, half over the water body, half over the land body like this? No. Why? Because the air which is over this water body will have different temperature and moisture content as compared to the air over the land. Different temperature and moisture content. Therefore, for the formation of this air mass, basic definition of air mass, I have just mentioned to you homogeneous characteristics. And homogeneous in a sense, temperature, moisture, so on and so forth. Therefore, the place from where air mass will be generated or originated, okay, should be a homogeneous surface. If it is a land area, it should be a land area. If it is a water body, then it should be water body, which means a uniform surface is required for the development of this air mass. That is one important condition about formation of this air mass. Clear? Uniform surface will be a source region for the formation of air mass. If the surface is not uniform, say for example, we have just taken the surface of water and surface of air. Now, and this is not uniform surface, one is land, one is water. But if it is land only, then one uniform surface. If it is water only, then also air mass can be developed because it is a homogeneous surface. Now within the land also, if it is having a mountain like this, then it is not a uniform homogeneous surface. So air mass will not be formed in this area. Why? Because for the air mass to be formed, it needs to have a uniform characteristics of the air. And such a non-uniform surface will not give rise to a homogeneous air characteristics. Another important point is, you see here, whether it is over the water body, air mass which is developing, or whether it is over the land area, if there is a strong wind which is blowing over this region, do you think a land air mass will develop? No. The point is very simple. whenever this particular over this area air is there, it is getting shifted away by the wind system which is present here. For the formation of an air mass, the air should remain steady over this homogeneous surface or uniform surface for at least some period of a time. During the process, this air mass will develop its homogeneous characteristics, after which, yes, it can be moved from one place to the other. But during the initial period of formation of this air mass, this particular air over the homogeneous surface should at least stay in a steady state for at least some few days. Therefore, even if you have a homogeneous or a uniform surface, if there is a wind system which is blowing over this, then air mass will not be formed. Clear? With that basic introduction, let us see. What is air mass? Air mass is an intense body of air. You see here its dimension. It is having somewhere around thousands of kilometers in length and breadth. Even the thickness is some several kilometers. So it's a very huge landmass. Now, one particular air mass can completely cover, if the country is small, can cover the entire country also. Okay, the immense body of air is known as air mass, having a homogeneous characteristics. The homogeneity is in the basis of moisture content or the temperature content. It is having a dimension of around thousands of kilometers and several kilometers in its thickness. Now, as you know, one air mass, why I am calling this as an air mass? I am calling this as an air mass because it is homogeneous. Therefore, the moment I go away from this air mass, then the air which is here will have different characteristics. If this is also having similar characteristics, then it could have been combined with this particular air mass. But I am having a boundary of this air mass, which means an area which is outside this air mass will have different characteristics. That is, different characteristics in moisture and temperature. Therefore, along the margin of an air mass, the weather changes quite sharply. Weather changes, why? Because you see here, if the temperature here is X, Tx, here this temperature will be Xy, which will be completely different from this. So the weather phenomena changes along this margin of the air mass. Clear? Equilibrium with the surface, that is the air mass source region, which I have just explained to you. Important part of the planetary wind system moves from one place to the other. Now, I told you the air needs to be steady over a uniform surface during its process of origination, during its period of formation. But once this air mass or the air over the uniform surface acquires the characteristics, homogeneous characteristics forming an air mass, after formation it can be moved from one place to the other. And how it is moved? It is moved by the planetary wind system which is flowing over the Earth's surface. Blowing of this air mass from one region to the other is also one form of transferring the global heat from one region to the other. Say for example, if a warm air mass is blown from equatorial region towards the polar region, then it is a form of a transfer of heat which is taking place. Clear? There are basically two types of air mass. One is called cold air mass, the other is called warm air mass. What is this cold air mass? When the air is colder than the underlying surface, it is known as cold air mass. Okay, air colder than underlying surface. Say for example, I have one uniform surface. If the air mass is colder than the underlying surface, it is known as cold air mass. Why? Because you see here, after formation of the air mass over its originating location, it can be moved from one region to the other. Therefore, after formation of this cold air mass over one, so during its formation, the surface is cold. That's why only, because depending on the surface condition, this particular air has acquired a cold temperature. but this particular air mass can be moved to other region. Now if it is moved to other region and the new region surface temperature is warmer than this air mass, it is known as a colder air mass. During this process, heating will happen from below. Why? Because the ground surface is warm as compared to this air mass. It is a cold air mass. Clear? Another one is the warm air mass. Similar, if the air over this is warmer than the surface below, then it is known as warm air mass. In this situation, this air mass will be cool from below. Why? Because the surface is cooler than the air above this. Clear? Now, this cold air, warm air is a relative concept depending on the surface. Depending on the surface. Now, classification of whether it is a cold air mass and a warm air mass, they don't have an absolute temperature. Like if it is above 20 degrees centigrade, it is called as a warm air. If it is below 20, it is known as a cold air mass. No. It all depends on the relative temperature between the surface and the air above it. Clear? Now, what are the source region? I have already mentioned to you how a air mass is formed. Therefore, the source region, the place from where the air mass is originating. You see here, air mass after formation can travel from one place to the other. Okay, so it is very dynamic in nature. But during its initial formation phase, it needs to be steady over a uniform area. Therefore, the source region should be extensive and broadly uniform surface. I have explained to you why it is so. Especially high pressure area or low barometric gradient, which means barometric is measures of pressure. Now pressure and wind velocity is directly proportional. Higher the pressure difference, means higher the barometric gradient, wind will be very strong. If it is low barometric gradient, wind will be very slow. So in such a region, why? Because strong wind region is not a conducive area for the formation, at least during the formation, because the air needs to remain over the surface, uniform surface, in a very stable form. Okay, primary source region are these characteristics you will find in tropical sea. Okay, in tropical sea, hot desert, uniform surface, Arctic region. Okay, now example, Sahara desert can be an important source region, Hawaii, interior Siberia. Okay, secondary are stagnation for a very shorter period. Now, North Pacific between Siberia and Canada. Now, middle regions, that is the middle latitude. Okay, middle latitude is not suitable due to cyclonic circulation. You see here, during the formation of an air mass, the air needs to stay stable over this uniform area for at least some few days in order to acquire the characteristics of this ground surface, thereby acquiring these homogeneous air characteristics resulting in the formation of air mass. In the middle region, there are many cyclonic circulation that take place, and because of this, the air does not get sufficient amount of time to be stable over a region. Therefore, in the middle latitude, you will not find a major source region of air mass. But it does not mean you will not find air mass. I already told you, after formation, air mass can move from one region to the other. Therefore, in the middle region also you will find air mass, but I am talking about the source region. Source region is absent in the middle latitude because of the presence of cyclonic circulation. Cyclonic circulation in essence, strong wind. Therefore, major source of the air mass is confined to tropical or the polar regions only. Clear? This is a source region you see here. Continent. Okay, it can be over water body, it can be over continent, it can be in the polar region, it can be in the tropical region. Now you see here, you will not find air mass developing like this. Why? Because if it is over the land, it should be over the land. If it is over the water body, it should be over the water body. But half land, half water, no. Why? Because the air over this continental land area is influenced by this land. Now this land temperature, moisture is different compared to this water over the water surface. Therefore, the air over this region will have different characteristics, not homogeneous, which means no air mass will form in this manner. If it is over the land, it should be over the land. If it is over the water body, it should be over the water body. Clear? Now, if the air mass source region is in the continental region, it is known as continental air mass. If it is over the water body, it is known as maritime. Now, we have just seen air mass can be either formed in the polar region or in the tropical region. It is absent in the middle latitude. Therefore, air mass which is formed in the polar region, it is known as polar air mass, tropical air mass. Important, kindly keep this in mind. Polar air mass, tropical air mass, maritime air mass, continental air mass. Okay. Now you see here, I already explained to you, after the formation of the air mass, it moves from one place to the other. When it moves from one place to the other, it gets modified. Okay, why? Because simple. Say for example, I have one air mass here. Okay, it is a very warm area. Now, this is a warm air mass. This is a source region. Now, I have already explained to you, during the formation of air mass only, it needs to be stable or steady over a region for some few days. After forming this air mass, it can move to any location. So, say for example, depending on the prevailing wind, if this air mass is moved to a new region here. Now, this, say for example, the new surface is very, very cold. This warm air mass will become this warm air mass over this. The surface condition is very cold. So, therefore, cooling will happen from below this warm air mass, which is the original air mass is getting modified. Similarly, if it is a cold coming to a new region which is very, very warm, then heating will take place from below. So, such kind of modification happens. There are basically two types of modification. One modification is thermodynamic. The other is mechanical. Let us see one by one. Thermodynamic modification is, it depends upon initial characteristics of the air mass, the nature of the underlying surface, okay, the surface over which it is formed, the surface over which it is going to, okay, the path followed, the time taken to reach the point of observation. All these are the important factors. Now, depending on the thermodynamic modification, air mass can be further divided into, okay, warmer air cooled from below or colder air heated from below, which means warmer air cooled from below or colder air warm from below. Means this one, warmer air cooled from below, means the new surface where this air mass has arrived, this is a cold surface as compared to this air mass. Therefore, this air mass will be warm from below. Warmer air, okay, so cooling will happen. This air mass will be cooled from below. Such type of a modification is represented by capital W. Keep this in mind, important. On the other hand, if this is a cold air, this surface is warm, so this air mass will be warm from below. Colder air warming from or heating from below. Such kind of modification is represented by capital K. Okay. Now, mechanical modification is because of turbulent mixing and sinking. Okay. S is upper level stability. That is warm air above, cold air below. Warm air aloof, cold air below. Stable. We have already seen atmospheric stability and instability. Cold air below means it cannot go up, which means this is stable environment. Therefore, it is known as represented by S. If the air mass is like this, because of mechanical sinking, lifting, during the movement of air mass from one location to the other, if the characteristics of the air mass results into warmer air above, colder air below, it results in stability and it is known as upper level stability, represented by small letter S. On the other hand, if there U represent upper level instability. That is cold air aloof. Okay, if cold air is over this warmer air below, then it is unstable. Therefore, it is represented by small letter u. I am not explaining stability, instability here because yesterday we have already seen what is stability and instability. But now you listen one very important point. These initials are very important. Why? Because we are going to see the classification of air mass. That's why I have already mentioned to you, maritime means M. Air mass forming over water is represented by M, over the continent by C. If it is in the polar region, represented by B. If it is in the continent, it is represented by C. Now, by T, tropical region. Similarly, air mass, if it is warmer air cooled from below, represented by capital W. Colder air heated from below, represented by capital K. If there is upper level stability, represented by S, upper level instability, represented by U. Another, clear? I hope that is clear. Now, based on this, the air mass are classified. If you understand the symbol that we have discussed just now, it is very easy for classification of the air mass. You see here, the air mass can be formed either in tropical region or the polar region. There is no question of source region of air mass in the middle latitude, which we have already seen. Therefore, air mass can be either tropical or polar in nature. So let me consider the tropical air mass here, T, represented by T. Now, this particular tropical air mass which is forming in the tropical region can be either over the land or can be over the water. If it is over the land, it is represented by C, continent. If it is over the water, it is represented by small m, that is maritime. Clear? Now, this continentally formed tropical air mass, after moving from its source region to the other region, can be modified. The modification can be of two types. It can be either warm from below or cold from below. Therefore, this CT air mass can also be further divided into CTK or CTW. I have just mentioned to you what is K stands for, what is W stands for. Thermodynamic modification. Now, I have mechanical modification also. Therefore, this particular CTK air mass can either be stability above, small correction here, it is U, okay, small u, or it can be instability above. Therefore, you just go and see this air mass. C stands for it is continental in nature, D stands for it is tropical in nature, K stands for it is a cold, and S stands for it is stable air mass. Similarly, you come to this. You see here, it is continental, it is tropical, it is cold air mass, but it is unstable air mass. Similarly, all of this air mass you can analyze in this manner. So this is how a classification of air mass takes place. Very important. Okay, therefore, you need to just understand the basic letter. Okay, let me run once for your benefit. You see here, polar air mass, tropical air mass, because it can be either in polar region, tropical region. It can be either in continent, over the continent, or it can be over maritime. It can be either thermodynamically modified, that is colder air warm from below, or warmer air cold from below, represented by either of capital K or W. Mechanical modification is upper level stability, upper level instability is represented by this. Now the playing or the combination of this in different arrangement give rise to different types of air mass. That is how the classification of air mass takes place. Similar classification of the polar air mass. Similar. In the polar region also, it can be over continent, it can be over maritime. Either of this can be modified. This is thermodynamic modification. And now mechanical modification, small correction here. Therefore, you just see maritime, polar, M stands for maritime, P stands for polar, K stands for cold, S stands for upper level stability of the air. So this is how different type of air mass are formed on the Earth's surface. Clear? This is how. Now, one very important point is the air mass which is formed depends on the season. In winter time, in summertime, they are different. Okay, so this is one of the example from the North American region. In North American region, that is US and Canada, this is the type of air mass which is formed during the winter pattern. Similarly, in the Asia, in Europe, you will find such kind of a air mass region. You see here. See, continental polar, okay, now maritime tropical, okay. You focus in this area once. This is during winter. In summer, see, continental tropical comes into the picture here. So, in winter and summer, different types of air mass are originated and they are moved from one place to the other. Whenever air mass move from one place to the other, they come in contact with each other, different air mass. The region where they come into contact with each other, it is known as front. It is nothing but the interface or transition zone between two air mass of different densities. Why? Because air mass means it will have different density, different temperature, different humidity, different pressure, so on and so forth. So such kind of a boundary or transition is known as a front. Okay. There are different types of front. There are cold front, warm front, occluded front, stationary front. Clear? Depending on this front, there are different weather and climatic phenomena. Okay, which we will take up in some other session. But we'll end the session here for today. Okay, we will meet again tomorrow at the same time, but tomorrow we will start a new chapter, that is oceanography. See, in this session in YouTube, we don't get sufficient amount of time. That's why I'm not able to explain everything in detail. But I have a plus course in Unacademy platform. You can always come and join me there, where we have many better tools to share with you the diagram picture, explain with you, interact with you. Okay. Otherwise, there are many important details that you still need to learn, like the frontal characteristics, the type of weather associated with the frontal characteristics in different types of front. Warm front, cold front, occluded front. Even occluded front can be cold front occlusion, warm front occlusion, stationary front, and how different types of, temperate cyclones are originated. That is polar front theory or wave theory given by Jerknis. Clear? Anyways, we'll end the session here today. We will meet again tomorrow at the same time with a new chapter, that is oceanography. Okay?